All right, so my name is JP Shermann, and what I do is I am the manager of search and findability. And I look at it from a findability perspective as SEO is a tactic of findability. So I look at how people find information, how they choose information, and how they consume information. So when I talk about search, I see search as not only just a technology, but as a behavior. So when we talk about Google as a search engine, that is a technology. When I talk about Solar as a search engine, that is a technology. But much bigger than that is how people find information, how people search. So at last count that I know of, Google does about 2 trillion searches per year, which is phenomenal. But search as a behavior, when you look at eBay, Amazon, Reddit, Instagram, all of these other sites, it is very possible that the search behavior itself is larger than Google. So this is why site search is so important, because there's likely more searches happening combined on site search than on Google. So the unfortunate thing is most of the time, around 18% of companies, only 18% of companies actually invest time, technology, and people into their site search. And we know that site search increases conversions, reduces abandonment, it creates better expectations, and it delivers a great experience for the user when they find what they're looking for. So search itself is fractured. We search in apps, we search on the web, we search using voice, and so search behavior is massive and it's fragmented. When I talk about search on a search engine, that is just one part of the behavior of search that humans do. And the thing is that if they're searching on your site, they probably think you have what they want. Otherwise, they wouldn't be searching on your site. And what happens is that site searches tend to be really not great. Most of my site search experiences are failures. And I know that Google is less than a second away. And if I know that Google is less than a second away, and I can't find what I'm looking for on your site, I'm gone. Not only am I gone, I remember the experience. So, when I do find the information I'm looking for on your site, am I happy? Not really. I mean, that's my expectation. Balloons don't drop from the ceiling when I find what I'm looking for on your site, because when I turn the crank on my car, it starts. That's what's supposed to happen. And users remember. They remember the bad experiences more than they remember the good experiences. They tend to lose trust. They know that they have other options available to them. And these are conversions essentially left off the table. If you have what they want and they can't find it, this is money that you've lost. So, let's talk about the actual search behavior of humans when they are looking for information. So they go through an active and passive search phases. Active search is that they have an intention in their head. They have acceptance and rejection criteria. Passive search is when they're scanning for information. It's a less, excuse me, apologize. It's a less direct behavior. So what happens when they're actually in their active search is that they are scanning for information on the page. They're scanning for useful bits of data. And the important thing to remember is the perception of value. How people perceive the value that you present to them through metadata, through design, through things like that, is one of the ways people recognize the information that they're looking for, and it's one of the ways that they make decisions. So, we're talking about, this is when we start talking about what's called an information scent trail. And an information scent trail is a human recognizing patterns of information scanned but not read. We're looking at vectors, how close words are to other words, how close images are to other words, And a great way to kind of look at this is, if you can look at a snippet in less than a second and decide, I know what this is about, or this is what I'm looking for, or this is not what I'm looking for, that is what the core aspect of an information scent trail is. The behavior of this is called information foraging. So as you look on a page, it could be a SERP, or it could be an actual content page, where, again, the user is scanning, they have acceptance and rejection criteria already in their head, and they're looking for bits of information that kind of coalesce around a single concept so they can make an acceptance or rejection action. And again, these are modified by value signals. I'm going to talk a little bit about value signals and how important they are, because this is the marketing part of search marketing. So the best way that I visualize an information scent trail is through a common word cloud. And when I'm looking for wine, I could potentially be looking for two different things: a purchase intent or an information intent. So when I start scanning the page or a SERP and I see words like Sauvignon, California, white, red, things like that, I'm looking at types of wine, which is closer to a purchase intent than words like rich, acidic, fruity, which is a property or information intent. So if you separate these two, as we start picking up words as we scan the page or the SERP, we start recognizing the intent of this page or the SERP. And so the unsaid intent, that was what we're looking for, we start realizing, I'm looking to purchase some wine for a party that I have tonight, and all I see are properties, information about wine. This is not where I need to leave. This is not where I want to go. I'm going to leave this information scent trail cold, and I'm going to look for a different one. So when I worked in e-commerce, I worked for a large e-commerce bike store. And one of the things that I found was, when you look at the SERP for road bikes, I see road bikes, brand, road bikes, brand, road bikes. This is not a good search experience, because it completely leaves out, why is this person looking for a road bike? Now, so what I did was, without permission, I changed the metadata, I changed the title, I changed the description tags on our products. So I did road bikes, lightweight and fast bikes for the open road. Reliable, affordable bikes for kids. Rugged, durable mountain bikes. This is when I started tapping into the actual intent of the customer, connecting with them emotionally, and setting up the immediate perception of value. When I compared road-trek bicycle to lightweight and fast bikes for the open road, this is a clear example of the immediate perception of value. And this is something that marketers need to understand, not just from a branding or SEO perspective, but from a connection to value, connection to people, connection to the humans that are looking for this information. So let's talk about what we can do to modify the results on our site search right now. First of all, most search engines ignore the keyword metadata. We know this. However, site search engines love keyword metadata. So if you are looking at your own site search results and they're garbage, the first place I go is their keyword metadata. And 9 times out of 10, they don't have any, because Google doesn't care about keyword metadata, because Bing doesn't really care about keyword metadata. Site search engines care a lot. Synonym lists. Inside most site search engines are synonym lists. Modifying, updating these synonym lists can clarify and disambiguate what your user is looking for. Boosted results. This is a great way, if you know the intent, to what they're looking for, you can curate your own SERP and not even have to rely on the natural results. You can make sure that this one thing ranks number one every single time. SERP features, things like facets, knowledge graphs, and other visual cues that allow a user to go where you want them to go or to help them discover what they're looking for. Clickstream data. A common feature of site search engines is clickstream data, where for a keyword and a click and a boost. A keyword, a click, and a boost. This is great if people generally search the same, but you eventually run into the problem where popular content is popular because it is popular. So it's a really important thing to understand that there needs to be counterbalances between just popular content because it is popular. And then personalization. Understanding who your user is can allow your site search engine to bias information geared towards what they're looking for. So in this case, I'm looking at a few site features that we built. One of them is Autosuggest and Autocomplete. This is a very standard feature that's on most search engines. These reduce failures, it increases click-through rate, and it sometimes allows a customer to find what they're looking for if they don't know exactly what it's called. Facets are important. Key matches are important. Think of key matches as like paid search ads that you run on your site for free. Knowledge graphs, and they can be curated or based off of an ontology. And then you have the natural results. So all of these things have their own click-through rates. The way that I measure this is through an out-click rate. Do people click out of my SERP? So in this case, my natural results tend to have a 60 to 65% click-through rate. My knowledge graph has a 70% click-through rate. My facets are around 30%. So I take all of these numbers, I weight them together, and I have an overall out-click rate, and that tells me overall what the health of my site search is. Another thing that we can do to determine intent is looking at location. So again, I'm going to go back to my bike example. For the single keyword bike tires, if you live near the coast, you can almost assume that they're looking for road bike tires. If you live near mountainous areas, you can almost assume that they're looking for mountain bike tires. But they both generally use the same keyword of bike tires. So understanding the location of your user can be a signal to bias results. We found this, we tested it in Santa Monica, and we did this in Colorado Springs, and we had a near double conversion rate, just based on this one simple change, using location as a signal to modify a single keyword. So, you need to measure your conversions through search. This is how you know that you're supporting the business objectives. Measuring dwell time. How long are people staying on your search engine? If they stay too long, it might be confusing. If they stay too short, they may not understand, or there may just be obviously bad results. And one of the things I like to do is measuring the time from query to consumption or conversion. While measuring time can be a little tricky, when I look at clear purchase intent keywords, and then I measure how long it takes for them to check out or put something in their cart, the faster they do that, I can generally say, through my small experimentation, that one, my search is doing well, and two, it's influencing behavior. So the great thing is that as SEOs, the things that we already do influence site search. Design. Always consider accessibility for visually impaired people, because they don't see search results the same way other people do. So always take into account accessibility. Snippet design. It doesn't have to just be 10 blue links. You could add images, you can add additional information, you can add content types, you can add so many different ways. Experimentation through snippet design is critical, and it has a real effect. If you sell cars, if you're in fashion, images are incredibly important. So don't just rely on the 10 blue links. Rely on what your users want and test it. Adding features like the click boosting, like a knowledge graph, and disambiguation. For example, one of the products that we have is called Satellite. When we have people looking for just the term satellite, I don't know if they want bits, I don't know if they want information, I don't know if they want training, I don't know what they want. So the knowledge graph allows us to disambiguate that user and allow them to give them different pathways to discover what they're looking for. Okay, so my point about all this, I've talked about the human stuff. The things that we can do to modify our site search, the result set quality, and things like that, are generally simple changes. Users will find what they want faster. They'll find what they want better. You can change the metadata. You can change the location recognition. You can do some simple biasing based off of personalization. You can change and test the design. Consider accessibility. So all of these things we can do right now to make our site search results better. And again, think about this. Don't be Google. Google has to try to figure out everything. We don't. Our universe is much, much smaller. We have a much smaller body of content to work with, and we can be better. And I think that's going to make a better web for everyone. So now, let's talk about machine learning. So at Red Hat, we sell free software. That's our business model. You can use our software, no questions asked. Which means that we're a subscription company, which means that we are a support company, which means that we live and die by the quality of support. And the faster people can find the answers to their support, the happier they are, and the more likely they are to renew. And people look for information in many different ways. My favorite one, and this is a real search query I get, my Linux is broken. I just find that incredibly funny because I don't know how to answer that question. So now I'm looking at intent. People search with different intents when it comes to our context and e-commerce. So I clarify my goals. Reduce zero results. That comes from working with content. Improve matching and results. And improve click-through rates. Those are my 3 goals. Doing that requires us to look at our content as a source of data. So if our content is unstructured, it's basically a giant pit of dinosaur bones. After several months and a lot of skill and some training, I can tell you that's an Albertosaurus. Or I can structure my data, and in less than a second, that's clearly a T-Rex. So this is the clear difference between the value of structured data. And think of it in terms of a machine. The machine will take time, resources, and a lot of wrong guesses to understand unstructured data. It will eventually start getting it right, and the results are generally better than not having data. But structuring your data increases the level of efficiency, increases the level of accuracy, and increases the customer satisfaction and results out of that machine. So, the other part of machine learning is structuring your information architecture. Having a good, clean site structure that is recognizable, crawlable, and just well-designed in categories. Having a taxonomy is amazing. Ontologies are great. Structured data also helps with this. So we have 2 things, information architecture and structured data. Those are 2 things that the machines start tending to looking for as we go to the goal of self-learning. Now, self-learning is the goal, but there are several other steps that we need to take. First of all is understanding the keywords. The machine, when you're using machine learning, it needs to look at the keywords. The second step, understanding taxonomies, and understanding entities, what things are. The third part is understanding query intent, query classification, and clustering of keywords. So what groups of keywords generally mean the same thing. Then we start looking at relevancy tuning, making the results better, A/B testing, and using plugins like Learn to Rank. What we use is Solr. Solr is a Lucene-based search engine. It's open source, and in most cases, free. It comes in many different flavors. Notch, Solr, Compass, Swift Type, all of these different things are all based off of the Lucene technology, and it's really, really good. And it's very flexible, very customizable. So when we start looking at the machine learning, how do we start building these tests? So we start with a simple question. Is this a cat or is this a dog? And we need to understand that the computer doesn't natively understand what a cat is or what a dog is. So we give it a data set. And in this case, it's pictures and pictures of cats and dogs together or apart. So it understands what dogness is and what catness is. It starts breaking it down into visual cues. This looks like a dog, this looks like a cat. So we take a training set, which is about 90% of the data that we have. We feed that into the machine. In this case, it's an image recognition machine. And then 10% we feed in as the evaluation set of pictures of the subject that it has never seen before. So it takes what it's learned from the training set and applies that knowledge to the evaluation set. And because there's a really cool algorithm, this one that I'm showing you is the Okapi BM25 algorithm, which is a good, strong, useful algorithm. It gives numerical outputs on dogs and cats. So in this case, the first picture, 99% chance that it's a cat. Second picture, 87% chance it's a cat. 62% cat percent on the statue. And the last picture, no relation to cats whatsoever. Now, understanding dogs and cats is one thing, but our users don't search, is this a dog or is this a cat? They look for things like fuzzy animals. So now we have our training set, we have our data set, we have our rules applied. How does it understand what fuzzy is? Cats are fuzzy, foxes are fuzzy, dogs are fuzzy, and sometimes blueberry pancakes can look fuzzy. So how do we know, how do we train the machine to understand fuzziness? Alternately, how do we train it to understand furriness? Which is, going back to the synonym lists, fuzzy and furry are very similar. So let's drill down into the content. This is how one of the machine learning starts looking at fuzziness and furriness as an attribute of an entity. We'll go down to indexing the content. And this is why content is so important to not just SEO, not just users, but also to machine learning. If you write about cats and you describe cats as fuzzy, if you describe foxes as furry, the proximity of those adjectives to the entity when indexed by the search engine in the machine learning context, it understands this is an animal and these are some of its attributes. So this animal has fuzzy in the content near it. This picture of a lizard has no word, fuzzy is nowhere near it. So one is fuzzy, one is not. This is one of the ways that machine learning can understand abstract concepts like fuzziness or furriness to the actual entity itself. And this is when we talk about Learn to Rank. Learn to Rank is a really, really powerful plugin that works in Lucene. It really it has three different aspects. Query independent, where it only looks at the body of content that you've created, that you have. It doesn't look at the queries, it just looks at the things that you've written. Query dependent, which looks at both the intent of the query and the content. And query level features, looking only at the query. So you can start looking at the queries as these queries have intent. This content has attributes. And there are ways, ideally you want to go for query dependence, where you look at the query and the content. But for simplicity's sake, I generally start with query independence, because it's the safest way to get the most data into the machine as possible. So let's go back to support. My goal is to deliver the right information at the right time to resolve an issue quickly through any channel they're looking through. That's my ultimate goal. So what we did at Red Hat was we selected a single product, OpenShift. We selected a single use case, troubleshooting. We wanted to focus on how people looked for information that would help them accomplish a task. And then we selected the content, which is our solution content type, which has a unique schema. So out of the entire body of content, about 30% of our content is solution-based. So what I did, 90% of that solution content went to our training partition, 10% went to evaluation. And we started running these tests to detect whether a piece of content, to detect whether a query, not the content, had the intent of troubleshooting. My Linux broke. Is that troubleshooting? Yes, clearly that's to me, because something is broken and they want to fix it. So we run the first evaluation through the algorithm, and it gives me the percentage value chance that this query is troubleshooting. And what I did, and this is where humans have to be a part of the machine learning process. You gave me a 70% chance, yes, 90% chance, yes, it's troubleshooting. I had to confirm or deny each one of them. So I went through thousands of these predictions and said, yes, this is correct, reran it with that additional data through it, and our prediction engine gets better and better. We did this several times, and at this point, we're running about a good 95% accuracy on whether a query is troubleshooting or not. So now, relevancy tuning, making things better. Signal weight. How valuable are the clicks to the content from the query? CTR weight. Does a click mean more than a high click-through rate? And the impression weight is, I don't just look at the thing that was clicked. There were 9 other results on that page. What about the things that did not get clicked? So I look at my SERP, not only as the things clicked, but things not clicked, and I measure them as impressions. Internal link weight and SERP impressions. And this is a very similar thing that Google goes through. I look at my internal links. How heavily do I weight those links? And all of these factors change the results for better and sometimes for much worse. And this is how tuning happens. But overall, we're starting to get into the point where we're able to start self-learning. Checking the weights of, again, the schema, the markup. Do we measure UGC? How relevant are the taxonomies and ontologies? And then relevancy tuning is really, really important. And this goes directly into the content strategy. When I look at the content, is it descriptive? Does it use the right words to describe an action? Is it task-oriented? Does it have diverse language and words? And again, I used to kind of shake my head and roll my eyes when people would say, content is king. Well, of course it's king. But this adds another layer of how it affects machine learning. And are there different content types? I have solution content. I also have e-commerce type content. I have many different types of content. How oriented is the language on the page? How oriented is the metadata on the page and the markup on the page to these overall goals? So overall, for our single product, single content type experiment, our baseline was blue. We had a fairly steady click-through rate. And over time, as we started getting better tuning on the relevancy tuning, on the search engine on our side, we started seeing better click-through rates as a result. And because we're a support company, when we see better self-solve rates, people are able to find the information that they're looking for without making a phone call. We saw a reduction in phone calls. We saw a reduction in cases. We saw an increase in case deflection. And every single one of those things costs a business money. So if I can deflect cases in support by having them solve what they're looking for, that saves us money. And then it's a revenue generator because it is more likely that these people are going to renew their contract because they're happier. And again, putting it all together, it's all about balance. Having good content, written well, using descriptive language to describe properties. Having good code and metadata, not ignoring your keyword metadata. And machine relevancy, it's going to attempt to understand what we're talking about, but the tuning and human involvement is incredibly important. And then, before you do any of this, define what success is, segment, and measure. Thank you so much. I didn't just do this alone, so there's a lot of people who are contributed to this, and thank you all so much.
Absolutely brilliant.
Thank you.
Wonderful. I absolutely loved that. Do we have any questions? Because I was kind of looking at that and talking to you the other day, just thinking, you're going from A to Z, building this search engine. It brings so much insight into, I mean, you're talking about ontologies, into structured data, entities, all these questions we're all asking ourselves, and you're building it yourself. How impressive is that?
It's cool.
And my question is, bring it all back to SEO, because that's what I'm obsessed with today. Has all of that helped your Google rankings?
Not directly. The things that I've learned by being able to tune and understand how search engines work is understanding how much weight having good content is, well-organized content is, how easy it is to index. And for example, like I don't even know how much time I have.
You've got another 8 minutes.
Oh, fantastic.
So we've got a long chat to go.
So there's a really, really cool thing about indexing and when it comes to search engines. So Google sends out a crawler to index your content. Most site search engines, so Google has kind of a pull method. Most other search engines have a push method. So my content gets indexed through an XML feed that goes directly into the Solr engine. So what does this mean? While there are definitely some indexing like best practices, you don't have to worry about crawlers when it comes to site search. I mean, you do, but in this case, you don't. So when you start building that XML feed, one of the things that we did was parse what is being fed to that search engine. We fed title, we fed content, we fed URLs, and we realized that we weren't feeding some critical information to our search engine to be a part of the index. So we added parts through the XML feed, crawl the structured, or index the structured data, index more of the metadata, index things like abstract field, content field, comments, and we were able to segment those out. So when you start looking at building a site search strategy, understand that you control so much of what gets put into the index. You can leave a lot of things out, and it kind of gives you that level of control and creativity to be able to essentially build the search experience that you want to give to your customers. And one of the things I found is by using that indexed from the XML feed allows me to add features to the snippets like title, content type, software product, software version, as a part of the snippet design. And I test these out. And sometimes they work, sometimes they don't. But the beauty is that if you want to build something unique in your SERP, make sure it gets indexed, pull it in, and make it a part of the design.
Yeah. Absolutely brilliant. I love that. And the other thing that struck me is how much work we need to do as humans to actually sit down and think, how am I organizing my information? And the answer is usually very badly.
Yeah, yeah. And I think the great thing is that when you start looking at it from a site search perspective, it's a very direct motivation to build a better architecture, to build better content. And while Google is definitely going to give you the best tangible rewards in terms of traffic, but when you are delivering more happiness and more relevancy to your users and seeing your conversion rates go from like a 2% from site search to a 7% from site search, it becomes an incredible source of revenue, and it connects with users. And honestly, when I find what I'm looking for, I'm happy.
Yeah.
And I get mad at site search so often because it's done so badly.
Yeah, and then that feeds into client retention, is that your client's got a problem, they search, and they find what they need, and they stay. They don't get frustrated.
Right.
And what I liked about that as well is the after-sales search SEO that people don't do, and they don't think that people, once they've signed up, they tend to think, oh, they just go to the site, but in fact they often go to Google, just type it into Google. And our comment yesterday was, it actually helps with that as well. Making sure that your clients, once they've bought, are actually finding what they need. We've got Dixon, who's got a probably more interesting question. It looks like it.
Not necessarily at all. Thank you very much. My question is around the amount of resource that Red Hat has that they can dedicate to, I guess, engineering. So if you take the employees at Red Hat and then take out all the sales support people that are actually sort of generating the income from the support stuff, and the three. Okay, so we're down to 3 people that are now doing all the technical crap on Red Hat. And then you've got this amount of time that you're dedicating to the site search functionality. How did you prioritize that over, I don't know, organic or PPC for that matter, or other methods of doing things? What brought this to the top of your agenda? And do you think it's realistic for other small teams like that to suddenly get this deep into, is there a level of scale at which this becomes sensible?
Okay, so that's a really good and a really big question. So we have 3 people. We have two engineers who are dedicated to search, and we have me. And I'd say about 10 to 20% of my time is dedicated to SEO now. And 80% of my time is dedicated into making our site search better. So we have dedicated specific resources to site search, which is good. When it comes to smaller organizations, something I like to recommend is SwiftType, because SwiftType it's powerful, it's customizable, it doesn't require a lot of development issues or skill, really. And you can build something that works in a day, and then you can modify it over time. So just as long as we remember that, like, just to kind of avoid the plug and play blindness, because it will work, but it takes time to understand what's going on. And my situation, and like, because Red Hat is a little unique because we are a big company, but we also have so few resources dedicated to it. And my success is measured by how much money I save on the support side and how many renewals I get from people who touched search X number of times. So it's a good question. It's something that I'm still trying to figure out, and it's something I'm still trying to balance. And I'm advocating for more resources. But there are things that smaller organizations, smaller businesses can do to start getting into this and looking into it and experimenting. The 2 other cool experiments, are there any other questions? Because I have 2 cool experiments that I'm running.
You've got 1
1
minute to
minute?
1 minute. 2
Okay.
great questions.
Okay.
Experiments.
So we're experimenting with queryless search. We have data that goes into our customers' systems, and it's able to predict if they're going to have, if the machine is going to bug out or something like that. We're collecting that data, and we're going to translate into that. We're translating that data into a SERP for the user to come in and see a queryless search based upon their insight data. So that's something that we're doing. The other thing that we're doing is looking at different SERPs, recognizing query intent, and building different SERPs for different recognized query intents. So it's all fun stuff.
It's all fun stuff. That's a great conclusion. Thank you very much. That was brilliant.
Thank you so much.
Big round of applause for JP.
Thank you.
Thanks, man.